When it comes to adding storage to your big box Amiga, you've really got two options, either a SCSI card or an IDE card. And while it could be argued that SCSI is the faster option, the more accessible option is certainly IDE. Now, there are loads of different IDE cards out there, but this new one from Matt Harlem, you might know him as Live2, this is the Ripple IDE, and I honestly think that this could now be considered as the go-to reference design for an IDE card. Dual channel, and this is using Live2's lide device driver. I'm sure you'll be familiar with that. It's compatible with practically all IDE devices out there, and a lot of us are running that driver on them. But this is the card that Live2 designed to go along with it. So let's take a closer look. Dual channel, like we said, buffered IDE at that, all controlled by Xilinx CPLD here, and that's a flash ROM that's holding that lide device driver. Also has another trick up its sleeve, but we'll talk about that later when we take a look at the Github. You've got positions here to connect up the access LED. You can enable or disable key power on the IDE ports. If you're at all familiar with these, I'm sure you'll know that one of the pins is normally missing on that. That's normally the key pin, but with that pin in there and with those two jumpers closed, well, that provides 5 volt down that extra pin, and it's able to power things like this CF card adapter. Just removes the need for having to run an additional power lead to that point. But one of the things that I particularly like about this little card is its size. Very compact design, because not only is it a half-length Zorro 2 card, you know, it's just exactly the same length as your Zorro 2 slot, and we are going to be testing it shortly using Diego here. But it's also a half height card, because if we compare it to one of my other IDE cards, this is the AT Bus clone. Well, this one is also a half length Zorro 2 card, but it's more full height, and you can see there just how much more compact the Ripple is. So this one in particular, this was actually sent to me by Gadget UK. Now, he did also include one big box of goodies, and we will get to that at the end of the video. But the reason that I mentioned that specifically is that this particular card, well, this is a very special one. Designed by Matt Harlem, built by Gadget UK. You can see a little bodge there that Gadget had to do to this, and ultimately it's going to be tested by me along with another of your favorite Amiga YouTubers, and then this card is going to be auctioned for charity along with a couple of other things. Gadget though also very kindly included another one for me. I get to keep this one. You might be able to notice a couple of subtle differences here between these. That's because this is a slightly later revision. This is the first release. This one's revision A1. So like I said, we're going to use Diego to test this with. But just before we do that, I want to jump on the Github just to show you a couple of other features associated with this card. So like all of Matt's projects, the Ripple IDE here is open sourced. The Gerbers are available for download along with the bill of materials. So you can get your own boards made at your PCB house of choice, be that PCBWay, JLC, or one of the many others. Now if we scroll down this a bit here, one thing you might notice is that the picture of the Ripple IDE there, that is different from the boards that I have. That's because it has moved on a bit since. It's now on to revision 5, and it's just using a different flash ROM. Otherwise though, the functionality and the features of the cards are more or less identical. So I want to take a look specifically at the features. Autoboot, well, you would expect that, wouldn't you, from any IDE card, but this one's quite nice. The ROM can be updated simply by booting the update disk. That's something that we're going to do in a minute. But Ripple also works with Kickstart 1.3. You get support for drives up to 2 terabytes. Anyone that's using a 2 terabyte drive on an Amiga is simply mad. I have a 120 gigabyte drive in my A2000, and I think about 110 gigabytes of that are free. But it doesn't just support IDE hard drives. You can use CD drives, DVD drives, zip disks. We're going to try it out later with a CD drive, and in particular, it's this bit. It can boot to CD. You see, the flash ROM that's on it actually has two banks. You have the IDE device driver in bank 0, and then in bank 1 you can put the CD file system, allowing it to boot to a CD. Something that we're also going to test later on. But then this just goes on to talk about the jumpers, how to order the PCBs, and how to program the CPLD. So like we've been saying, it's using Live2's lide device driver. So if we go to the GitHub page for that, we can then go into releases, the current version being 40.11. And if we scroll down here, we can download the update ADF. So within this repository, it also talks more about the CD boot feature. To get that working, we need to get the boot CD file system from OS4. And as I said, we need to write that to bank 1 on the flash chip on our Ripple. We'll do that later though. First thing I want to do is we'll just test this as is. We'll see what version of lide.device it is running. I'm fairly sure it is running an older version, but we'll check what it is and then we'll try and update it using that ADF. We've got a Ripple in Zorro slot 2 and I've got 8 meg of fast RAM here in Zorro slot 5. Another card from Live2 actually, that's the Gotta Go Fast RAM 2000. Just going to use this CF card. It has a fairly basic install of 3.1 on it. And before we go updating it, let's see what sort of performance that gets. Now, IDE on an Amiga is limited pretty much to the speed of the CPU. You know, the CPU is controlling it all. So if you were running this on, say, an accelerated Amiga, you are going to get better performance. But this is just 7 MHz 68000, although with the fast RAM. So let's run sysinfo. We'll go into drives, D80, and let's see what sort of speed we're getting. Just over 1 megabyte a second, 1075830. That in itself honestly isn't bad. In particular, if you compare that to, say, a stock A600. Here's a screenshot from my 600, granted with no fast RAM, but at that you can see it is considerably slower using the onboard IDE. In fact, we could pull that out and let's see what sort of speed we get now. And yeah, a little bit slower because we don't have the fast RAM, but still more than twice the speed of the IDE on a stock A600, which is comparable machine speed wise to this A500. But I think we can do better than that. Even with the fast RAM in, I think we can. Let's just see what version of lide.device we've got on this card. And we can do that by going in here, system, running shell, and version lide.device. Yeah, version 40.5, but we know it's up to 40.11. Let's update it using that ADF. Although to make it handy for myself, I'm just going to grab my GoTech rather than using the real disk drive. Okay, the ADF we need is on that. I believe it is a bootable disk. And yeah, there it is, lide flash updater. So the current version it is found, as we know, is 40.5 from December 2023. Do we want to update this device? Yes. And it's just that simple. So we'll take that out, hit reset, and let's see what sort of speed it gives us now. And yeah, there we are. I would say approximately 100k a second faster. Doesn't sound like a lot, but you know what, 10% faster just from running an update. Like I said though, the IDE drive speed should scale with your CPU, and in fact we'll maybe test that later by trying this out in one of my faster Amigas. So next thing I want to do with this, and considering that it's a dual channel IDE card, let's put something into the second channel. Now, no point in putting another hard drive in there, but we can put a CD drive. And as part of that, I want to test the CD boot feature. Although to do that, we first need to write the CD file system to bank 1 on the flash ROM. So we're going to write boot CD file system to bank 1 on the flash chip using the lide flash utility. You can see the syntax of it there. So it's just lide flash -c and the name of the file system. Boot CD file system. Enter. Yes, this board does not support flashing bank 1. Oh dear. And sure enough, we go back to Live2's GitHub. The support for loading CD file system from flash was added at revision A2. That's the prototype revision A. Even my own board is just a revision A1. So this ain't going to work. Or well, the autoboot side of it isn't going to work. But we can still add a CD drive. We can mount it within Workbench as CD Zorro. So let's try and do that. Right, please excuse the rather dodgy looking balancing act, but we've got CD drive hooked up here with one very ropey IDE cable into the second channel on Ripple. We'll just stick a CD in for now, and what better to use than Amiga OS 3.2. I don't actually think I have used this diskette for anything, because I do mostly just run 3.1 on all my machines. I'm not going to install it on this 500, although what we might do later is try to use Ripple to install this on my A4000. So to add a CD drive to your Amiga within Workbench 3.1, you need a couple of things. A CD file system, the device driver, and something to mount it as. Well, we're going to mount it as CD Zorro. The device driver is already on the ROM on our Ripple, as in the lide device driver. And then we need the CD file system. For that, we're going to use OD file system, another open source project actually. This one created by Stefan Reiner. This is also available on GitHub. I'll leave a link to all this in the video's description. But from the ADF that you can download from GitHub, we need the CD Zorro, that's what we're going to mount this as. We need the OD file system. OD file system, which we're just going to copy into L. And CD Zorro, which we're going to copy into devs and DOS drivers. We then need to edit the tool types for CD Zorro. So right click, icon and information. And we just need to change that device to lide. Drive is connected to unit 2, because the way this works is that the primary IDE channel here, well, that is 0 and 1. Remember, each of these channels can support a master and a slave device. So that's 0 and 1, and then the secondary IDE channel is 2 and 3. CD drive here is set up as an IDE master, so it is currently connected to unit 2. We also, though, need to modify the mount list associated with CD Zorro, and we'll just do that from within shell. We need to modify this section of it here, where it says file system. As you can see at the minute, it's still pointing to the floppy disk. We don't want it to do that. We want it to point to our L drawer, because that's where we copied the file system to. We then right click, save that. And in theory, when I reset the machine, the CD drive should be automatically mounted, and that OS 3.2 disk should just appear here in Workbench. Let's try it. The drive is spinning up, which is a good sign. There it is. OS 3.2 CD. We're not doing anything new here. Plenty of people have ran CD drives on their Amigas for a long time. In fact, I had a CD drive hanging out the back of my A1200 way back in the day. But I do think it is particularly cool having the Ripple IDE here with both primary and secondary channels on it, with CF card, run Workbench, and the IDE drive here. Now, the drive itself is maybe a bit cumbersome, certainly in the way I've set it up here, just hanging out the side of the 500 on Diego. But what might be a more neat solution, or you might say more modern solution for this sort of setup, would be to use something like this. A Zulu IDE, you know, I could envisage a setup with your Diego, say in a custom case, with these half-height cards that you'd maybe have your CF card accessible through the top of a custom case, and you could have your Zulu IDE mounted in here somewhere as well. In fact, I think it's these half-length cards that are just perfect for the likes of the Diego 500, and in particular the Ripple, being so small, being so shallow a card, it just matches perfectly with this sort of setup. Well, it was at this point in the video where I was once again going to tell you how impressed I am with the Ripple IDE, but how disappointed I am that we can't use the CD auto boot feature with this card, or with this revision of it anyway. Well, had a conversation with Live2, and we can hack that functionality into this card. It just needs one baud wire between pin 11 on the flash ROM and pin 46 on the CPLD. So I do think it would be worth trying to do that, because personally I do think the CD auto boot feature of this is one of the highlights of it, so let's give it a go. Now, it is quite fine pitch stuff. Pin 11 on the ROM is on this right hand side, just beside capacitor C4 there, so it's going to be quite hard to get to it. So rather than try to lift the pin on the chip when it's attached to the board like this, I'm going to desolder that chip, then we can bend the leg up over the top of it, resolder the chip, and patch a wire across to the CPLD. Luckily we don't need to lift the pin on the CPLD, that pin at the minute is just floating on that, so we can just attach the wire directly to it. But pin 11 on the ROM, well, it's currently tied to ground, so that's why we need to lift it. We'll just use hot air to take this off. And hopefully if Gadget UK is watching this, yeah, isn't cringing at me undoing all this hard work here. But as I say, I do think it's worth just bodging this wire in here just to get that CD auto boot function working. Just go over this with a bit of braid here. That'll just make it easier for us when we go to refit the chip. Now we just need to lift pin 11 on this, but I think what I'll do is bring in the microscope. So yeah, I still have to use this little scope. My other big one, it just gave up on me. I haven't got a chance to try and fix it yet. That's why the image is a little bit blurry, but we can see there, that's the pin 1 marker. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is that one which we need to lift. There we are. That's the pin up. And now we can just resolder that to the board. Let's try and get one corner of it here, and then we can check the alignment of it and all. And I know I've bridge pins there, but that's okay. As I say, I'm just tacking it down because I want to check alignment on the other side. And yeah, as you can see, it is off a bit. That wants to be more there. Even this scope's not very good, is it? Because the image keeps freezing on me. Right, I think that's that side done. So just same again on the other side, and then we'll run a wire. Way too much solder on that. That Amtech flux, it isn't really that good. I'm going to have to get myself more chip quick. I just cannot get on with that stuff at all. It's really hard to get solder to flow properly with it. Yeah, there's so much solder on that, I think I'm going to have to use a bit of wick. Give me a minute to try and get this on, and then we'll be back. Well, that took longer than I care to admit. Some new chip quick has been ordered, but you can hopefully see there that this side of the chip is soldered down, apart from that one pin there, which is sitting up in the air. So let's try and get a little bit of wire attached to it. Now we need to take this across to pin 43, did I say, on the CPLD? Just let me check that. No, sorry, pin 46 on the CPLD. That's on this side. It's the third one in from this end. That's where I'm getting the 3 from. Right, I think that got it. You see, give it a wiggle. Yeah, that's okay. That's on there. But that's the budge wire in place. Now, we do need to write a custom version of the JED file to the CPLD. And by that, I mean it's a custom version for this revision A board only. The JED file that's on the Github, that is correct for all other versions of the Ripple card. But we'll do that just using the Raspberry Pi. As always, I will give this a bit of a clean, just as it is. And then we'll try writing that boot CD file system into Bank 1 on the flash ROM. Well, it still works. Always a good thing after you've been tinkering. Updated that JED file on the CPLD just in the usual way, using the Raspberry Pi, connected over SSH just to flash it. So, speaking of flashing things, let's now try and write the boot CD file system to the second bank on that ROM. Once again, we're doing that from within shell. So it's lide flash -c boot CD file system. Yeah, seems as if our budge has worked. It has successfully written and verified that new code in Bank 1 of the ROM. So when we reset, all being well, it should just auto boot to that CD. I'm fairly sure that 3.2 CD is bootable. Well, it did start to try and boot to it there, and let's give us an error. So went and spoke to Live2 about this problem. What's going on? Well, nothing to do with ROMs. It's all to do with the CPU. This 500 just has its 68K. But that boot CD file system, that actually needs an 030 at minimum. That's why we're getting that error. Matt was able to recreate the same problem, just using the 500 with the 68,000. So that's not going to work, but we're not beat. Remember earlier when we had the CD drive working with this using OD file system? Well, on the GitHub for that, there is a ROM version of that OD file system. I suggested that to Live2. He had to modify it slightly so that it will work with our Ripple here, but we do now have a ROM version of that for this card. That actually solves another problem, because that boot CD file system, it was just part of OS4, so you'd need to own OS4 to get that, whereas using OD file system, it's completely open source, it's free, so Matt's going to include it within the LIDE update disk. I have a copy of it on our flash drive here. So let's boot into Workbench again, reflash our ROM, and hopefully it will now boot to CD. It's still throwing that error. So we'll just boot the Workbench from floppy here, or well, an ADF image of it. Then I can go into the Workbench drive on our CF card, and we can just remove that CD0. I'll just stick it in the storage for now, because we will need it again later. But if we remove that, then that should allow the machine to boot again, just to the CF card. It's not going to try and look for the CD drive without that in there, you know, without that CD0 in DOS drivers. Yeah, booted okay this time. So let's try and update that flash ROM. And this time it is OD file system -LIDE. Right, that should be it. So let's try our OS 3.2 disk again. Let's stick that in the drive. Let's reset. Yep, it is reading off the disk. Access light's flashing away. Disk is spun up. I think it's booting. I've been waiting 5 minutes. It's still loading. I'm bored. I give up. Let's try this bubble disk. This should hopefully load a lot quicker. There, you can see because I have removed that, it's throwing up on the screen there an error message. But if you look at the top of that screen, copyright 21 Hyperion Entertainment. So yeah, it was definitely trying to read off this disk, or definitely trying to boot off this disk. It was just taking forever. Well, it's playing music, which is a good sign, but we're not seeing anything on the screen. That might be because it could be using an AGA screen mode. Because while Bobble, yeah, okay, it's OCS game, but that compilation disc was made for the CD32. It sort of starts up to like a bootloader. You can pick between Bobble, Rainbow Islands, and Parasol Stars, I think. So unfortunately, it's a common theme. Now, I don't think it's a problem associated with Ripple per se. Rather, my CD collection of Amiga software is all based around my CD32. This thing is not a CD32. And even games, you know, such as Cannon Fodder, which should run on this hardware. I know that says CD32, but it's still just the same game, you know, that was on the A500. The problem though is that this version of it is doing calls to the CD32 hardware. For example, it's trying to tell the CD drive to run in 2-speed mode, but it's sending that command to this drive. That drive doesn't understand that, and so it just crashes. But I wonder if we might have more luck switching to an AGA machine. Well, hopefully you remember this machine. My A4000, still looking to get a case for it. It's on the list. But let's see if this thing will maybe boot to OS 3.2. Might be able to see that I have already written a set of 3.2.3 ROMs for this. I do hope to set up and install 3.2 on this CF card. That's a different one to the one we were using earlier. That's just an 8 gig CF card, but I want to set that up for this machine. And it is booting, and sure enough, there it is. It's booted. There's the Amiga OS 3.2 CD. We've got it open there. Install. I'm going to try and set that up. Not going to bore you with the whole process of it now, but it should be straightforward enough. Just need to partition the CF card, format it, install. That should be it. Well, took about an hour in the end because I wanted to update it to 3.2.3 as well. Had to do all that just from ADFs using the GoTech, but it should now boot. Yep, there we are. OS 3.2, although it is 3.2.3. And I finally found use for this CD. Haven't actually been able to use that for anything yet. So I want to try and load some software again from CD. This is a copy of Road Avenger. I'm still not sure if we can run any CD32 games, because while this is an A4000 and an AGA machine, it doesn't have the Akiko chip from the CD32. That chip is handling the CD drive, so any games that are making calls to that, they're just not going to work. But we can see Road Avenger there. Rather than try to launch it from within Workbench though, let's reset and let's see if it will just boot. This one didn't work on the 500, although I think it might have been running out of chip RAM. That machine actually only has 1.5 meg of chip RAM, Plus, I'm not sure if you can actually run this game on the 68,000 CPU. We've got the BFG in here with the 060, loads of RAM, and yeah, there it goes. Apologies for all the noise off this drive, by the way. I know it is very noisy in the video. But you see that running okay there, booting directly from the CD. Let's see if we can try another title. Will we try a CD32 game just to see what it does? This Roadkill. Again, it is starting to load. And there's what I was talking about earlier. CD2X speed failed, return code 34. So that game, when you do boot it on the CD32, you can actually see it through the window. It starts off spinning slowly, just at 1x speed. Then it accelerates as it starts to play the intro to that game. It's got an FMV intro. But it's obviously trying to do that here. It's trying to send that command to the drive. But this drive obviously doesn't understand it. So we're getting the failure. With the likes of that bobble disc. That's one of the CD32 compilation discs, essentially using WHD load to run those games. Let's see if it does anything. And yeah, okay, it has this time brought up the selection screen. There is a bit of corruption on it there, but let me plug in a joypad and see if we can just make a selection. That drive is incredibly noisy. But no, it's not working. You push the button, nothing's happening. No fault of the Ripple though, it's just the software I'm trying to run here just isn't compatible with this hardware. It needs a CD32. But to finish off today, let's do another speed test of the CF card here. Since we're in a far faster machine now, we've got an 060 here running at 50 megahertz. Granted, it's just the LC variant of it. I don't have my Rev 6 in this. And yeah, sysinfo ain't gonna work right, sure it's not, because it doesn't like 060s. But I wonder, can we still get a drive speed test? And yeah, there we go. Just over 2.5 megabytes a second. That's a scaling with the CPU. Although granted, in this situation, our Zorro 2 card here is probably the bottleneck rather than the CPU itself. Although, how does this compare to the A4000's onboard IDE? You don't get any key power from the onboard IDE, so I've had to borrow this off the GoTech. Just disconnected that in the meantime. Might mean it takes an extra couple seconds to boot while it tries to look for a floppy drive, but it should get there. Yeah, there we are. So what sort of performance do we get now? And surprisingly, it's actually faster. I did not expect that. I expected it to be about the same. The benefit though with the Ripple really is its CD boot function. And I'm sure it would be possible to patch CD32 ISOs in some way to get them to boot natively on an AGA machine such as the 4000 here, using something like this, or indeed on a expanded A500 where the game doesn't require the AGA chipset. Out of interest, we try and change to the 040 CPU card. But let's see what sort of speed we get now in sysinfo. Yeah, okay, has slowed down a fair bit. 1.6 megabytes a second on IDE Zorro. I think this time the bottleneck has moved back to the CPU, and possibly because this CPU card itself doesn't have any onboard memory. It's relying on the fast RAM on the motherboard over here. It's nowhere near as fast as the RAM that's on the BFG. Then for the sake of completeness, let's try this in here again. We'll benchmark it one more time using the 040. So it's about 1.6 before. And yeah, pretty much the same. So that's the Ripple IDE, a new standard for integrated drive electronics in your Amiga. Oh well, that's what I think anyway. I'd love to know what you think about it. Please let me know in the video's comments. Is this something that you'd like to add to your big box machine? Now it is just a Zorro 2 card, just a 16-bit card. And well, that's because IDE itself is just 16-bit. There would be no point in trying to make this a 32-bit Zorro 3 card. You're not going to gain anything from that. And so you might argue that ultimately SCSI cards will always be the faster. And yeah, I suppose that is true. But at least with IDE, it's really just plug and play. You know, you just plug in the drives. So long as you've got the device drivers and the file system within Workbench, it just works. No mucking about with drive IDs or termination or any of that other nonsense that comes with SCSI. IDE, from that point of view, is just a lot easier to use. So this one, I'm going to keep this for myself. This is the Riv A1 that Gadget sent. You can see that I've also modified this one to add the CD autoboot feature. But this one, the prototype board, the Riv A, this one is going to go on to one of your other favourite Amiga YouTubers. This is going to Andy from HBR. He's going to do some further testing with it. And in fact, within this box that Gadget sent, there are some further goodies to be moved on to Andy, but Chris also included quite the selection of little PCBs, CRG Links cartridges, including a little 3D printed spacer that I made for him. And then these things, this is really cool. This is Gadget's Marine, and this is an FPGA replacement for the Amber chip in an Amiga 3000. Now, I would have to get myself an Amiga 3000 to even consider using this. And he has give us, what, 5 different versions of that board, which is very generous. But there are potentially other things that we could do with a Marine. You'll need to leave that one with me though. I do have an idea for it, but you'll need quite a bit of research. And then we've got 4 PCBs for ROM adapters. Essentially just letting you use a 27C 400 in place of a 27C 4096. Oh, he did also include a note, which has actually just reminded me that within this box, the other thing that he gave me was the UV lamp. No doubt you've seen me using that in a couple of recent videos. Very, very handy thing for drying solder mask. So thank you very much indeed for this Gadget. Because using solder mask where you're repairing damage on a PCB, it's just so much better than using nail polish, which is the way I used to do it. So that is fantastic. And then perhaps the most important thing that I included was some sweeties, some chocolates. So thank you very much. I'm going to go and enjoy these. But hopefully you enjoyed this video. As I said, please let me know what you think about the Ripple IDE. Is it something that you'd want to add to your big box machine? But that's it. Thank you very much for watching, and I'll see you next time.